Night or day, this mile-long steel mill hums with purpose. Built in the 1970s by Davie United and rolling its first ingot in January 1973, today this bloom and billet mill processes 2 million tons of steel annually, a relentless industrial heartbeat. It starts in the SOA bay, where freshly cast blooms are unloaded onto flats. AVIIC crane lifts them from flats into soaking pits, where each bloom is heated, 1,350 degrees Celsius for cutting steel, 1,275 degrees Celsius for tire cords, to put them in perfect shape for rolling. Once soaked, blooms are transferred via ingot buggies and pushers onto the mill racks. Through the 2-stand primary mill, blooms shrink step by step. The 10-stand continuous mill finishes them into billets, using reversing rollers in HV sequences, improving consistency. Defects are scrubbed by inline scarfing torches, and ends trimmed by a 1,200-ton shear, waste metal recycled on site. To maintain high product integrity, both the front and tail ends are cropped automatically before entering the next stage. Each transition is logged and monitored by operators stationed along the line, ensuring issues are caught before they propagate. Quality control is everywhere. After the roughing and intermediate mills, roller calipers verify sizing. Then billets hit the finishing mill, followed by a flying shear to cut to customer lengths. Each piece is hard-stamped with a cast number for traceability and travels via golf buggy-driven shift teams through cooling banks. Next, bars dive into quench tanks before advancing to either visual or automatic inspection. A roll straightening machine aligns bars up to 160 square millimeters, prefaced by shot blasting and passing through the thermomatic system, which sprays defects for later grinding. Bars are color-coded by chemistry and directed to grinders or ultrasonic testing for internal inconsistencies. High-grade bars emerge ready for forging. All operations run 24/7, handling 20,000 tons of billet weekly. Steel is stored or loaded to road and rail via traffic-controlled wagons for delivery. Watching this massive choreography of cranes, presses, and furnaces, it's engineering on a grand scale. From molten bloom to finished billet, it's precision under pressure, rigor in every pass, and a relentless drive to exceed quality standards. Watch how a steel drum goes from a simple cylinder to a rugged, ribbed container that's ready for heavy-duty use. This is where the magic happens. On this high-speed line, each drum body enters with a smooth cylindrical form. The first two forming machines press into the sides from both ends, creating bulged reinforcement rings near the top and bottom. These aren't just for looks. They strengthen the drum walls to resist denting and stacking pressure. Next, two additional machines roll in more beads along the body, adding structure and increasing rigidity. Watching them puff outward under force is oddly satisfying. Steel shaping steel in perfect sync. Then, alignment checks ensure the beads are evenly spaced, maintaining balance and strength. A quick dimensional inspection follows to catch any forming deviation. Automated lifters transfer the drum to the next station, reducing human handling and keeping pace with the line. Edge trimming units then remove any flange burrs or sharp overlaps. Even a tiny miscut here could ruin the final seal. Sensors continuously monitor speed and position, ensuring each operation stays perfectly timed. Any error triggers a pause for human inspection, an extra layer of quality control. Then comes assembly. The bottom cap is aligned and welded, sealing the base with a precise circular weld. The top lid is then placed, featuring an opening or bung hole, and gets fixed in place, either by welding or mechanical seaming, depending on the drum type. The drums roll forward to surface treatment. First, they are cleaned and degreased to remove any oil or contaminants from the forming process. This prepares the metal surface for coating. Next comes painting. Whether powder-coated or wet-sprayed, each drum is evenly coated with a weather-resistant finish. This layer not only protects against rust, but adds a polished, uniform look that screams durability. After curing in an industrial oven, the drums exit looking brand new. Some models may receive stenciled markings or serial numbers before heading down the line. It's easy to overlook how much engineering goes into something so utilitarian, but this process is anything but simple. From mechanical beading to precision welding and flawless finishing, every step is part of a well-oiled system. G83K4. Molten aluminum, roaring furnaces, and tight tolerances. This is die casting in action. At Aluminio Inyectado Valencia, it begins with high-quality alloy ingots fed into Hormesa furnaces. After melting, Italpresse machines inject the metal into molds. Post-trimming, each piece is deburred, shot blasted, and inspected, precision crafted from heat to finish. Designing reactors, casting steel, assembling systems. AEEM's workflow covers power plants from core to delivery. This isn't just a lathe, it's a turning center engineered for complexity. Meet the Touro Deco 36 terabytes, designed for long, intricate parts like orthopedic implants, where flawless internal threading and deep hole drilling are essential. At the heart of this system is a rotating guide bush, enabling bar stock up to 36 mm in diameter and 600 mm in length to be machined with high stability. Its turret sits on a B-axis for full angular freedom, allowing complex contours and angular operations without repositioning. With 57 tool positions, 36 of which can be rotating, it handles simultaneous 5-axis machining with ease. Before any cut is made, the bar feeder loads each workpiece automatically, ensuring consistent material flow. During roughing cycles, chips are efficiently broken and evacuated to keep surfaces clean. And throughout the process, sensors monitor spindle load and vibration in real time, adjusting parameters to protect both tool and part. Watching this machine cut a 250 mm intramedullary nail is mesmerizing. The deep hole drilling module, located right next to the machine, delivers internal threading with surgical precision. That's no exaggeration. These components go inside the human body. Dual spindles each deliver up to 53 Nm of torque, enabling aggressive cutting while maintaining dimensional integrity. The heat exchanger ensures stable thermal conditions, crucial for tight tolerances in medical-grade parts. It connects easily to a cold water network or chiller system, minimizing thermal drift during long cycles, and smart autonomy is built in. The integrated cutting fluid system includes high-pressure pumps that maintain optimal chip evacuation, cooling, and lubrication, reducing downtime and wear. It's fascinating how much intelligence is packed into such a compact footprint. From angular turret control to Z2-axis coordination, Every part of this machine works in harmony to produce parts that simply can't fail. Thick armored cables don't stand a chance. Watch the V200M slice, strip, and separate with ease. It's easy to overlook the tools in your garage until you see what goes into making them. At Bestone Tools, the journey starts with in-house designing, followed by CNC machining and engraving for accuracy. Steel blanks are cut, forged, and trimmed into rough shapes, then punched and broached to define key features. Profile and shank grinding refine each contour with care. Next comes heat treatment to enhance durability, followed by vibration and electroplating processes that prepare the surface for final use. Every piece is lab-tested, inspected, and laser-marked for traceability before being packed. Watching raw steel evolve into precision tools through fire, force, and finesse, it's engineering with grit and purpose. Here's how massive steel beams are made with speed and precision. Flat plates are first cut with CNC guided machines, up to 150 millimeters thick. After that, they're welded into H-beams, bent to spec, shot blasted for a clean surface, and painted. Each piece is carefully inspected before delivery. It's industrial work, streamlined and seriously satisfying to watch. What does it take to machine small parts from tough materials with absolute precision? Enter the Star SV32 sliding head lathe, a Swiss-type CNC marvel engineered for complexity and speed. The process starts with a bar of steel or alloy fed through a guide bushing. Unlike conventional lathes, the sliding head design allows the material itself to move, supporting the workpiece close to the cutting point. This drastically reduces deflection, which is crucial when you're dealing with long, thin, or high-tolerance parts. With multiple tool posts operating in tandem, the SV32 can perform simultaneous front and rear machining. It's mesmerizing to watch, a ballet of synchronized cutters carving, turning, drilling, and tapping all at once. The turret system supports driven tools, meaning cross-milling and angular operations can happen without stopping the spindle. As each tool engages, the machine adjusts in real time, compensating for any material inconsistencies. A bar feeder keeps fresh material coming non-stop, enabling lights-out operation for maximum efficiency. Sensors monitor cutting forces and spindle load, ensuring nothing goes off spec. If anything drifts even slightly, the system corrects it automatically. No pause, no human needed. One of the most impressive features is the machine's ability to work on different axes simultaneously. Complex geometries? No problem. Deep internal threading? Handled. Minute surface finishing? Done with grace. The precision here isn't just tight, it's repeatable, shift after shift. Chip management is handled by an integrated conveyor, and high-pressure coolant systems flush away debris, keeping the work zone clean and thermally stable. That's key when tolerances are measured in microns. Parts emerge fully formed, often requiring little to no secondary processing. In fields like medical, aerospace, or precision tooling, that level of output isn't just helpful, it's mandatory. Every sound from this machine, every movement, It's proof of how far automation has come in high-precision turning. The heavy-duty line shapes axle shafts with brute force and tight tolerances. Dies are crafted in-house, then transferred to press lines, where red-hot steel meets precision tooling. Watching raw metal transform under such pressure, it's power, precision, and process in perfect sync. From glowing steel rods to industrial-strength coils, this is the journey of a heavy-duty spring. It all begins with large-diameter steel bars, ranging from 35 to 90 millimeters, heated until they glow bright orange. That color means they've reached forging temperature, typically around 1000 to 1100 degrees Celsius. Once hot enough, the bar moves into the coiling station. Here, a programmable forming head bends the softened steel around a mandrel, shaping precise loops with impressive force. Watching the red-hot steel curve like clay is mesmerizing. Industrial craftsmanship in motion. The coiled spring is then transferred for quenching. Immersion in oil or water rapidly cools the metal, locking in the shape and improving hardness. But the process doesn't end there. Next comes tempering, reheating at lower temperatures to relieve internal stresses and ensure flexibility under load. Afterward, every spring undergoes shot peening, where tiny metal beads are blasted onto the surface to boost fatigue strength. Dimensional checks and load testing follow, ensuring each spring meets the demands of railway systems, agriculture, or off-road machinery. These springs don't just hold weight, they carry industries. How does a flat steel coil transform into the sharp, rigid hollow sections holding up buildings and bridges? Let's take a closer look. At this facility in Tianjin, production begins with raw hot-rolled steel coils, uncoiled and fed into a forming line. These strips are gradually shaped by rollers into a round tube. Precision is key. The edges are then welded together using high-frequency electric resistance welding, ERW, creating a clean and continuous seam. But here's where it gets interesting. The round pipe moves into a shaping section, where it's pressed into square or rectangular form using sequential rollers. You can almost hear the metal settle into its new identity. Next, automated saws cut the hollow sections to length, each cut timed to the second. Products then undergo straightness correction, surface inspection, and zinc coating if galvanization is required. Whether black or galvanized, each hollow section must pass quality checks before packaging and shipment. Its efficiency, geometry, and durability rolled into one.